Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we first meeting in the fifth International Symposium and Intelligent Manufacturing and Mechatronics SIMM 2023, which conduct by the Faculty of Mechanical Engineering and Technology, University Malaysia Perlis. Alright. So today, for my presentation, I would not like to make it very long. Okay. So this is the presentation. The topic is mechanical properties of epoxy ultra high molecular weight polyethylene variant for hip implant proposal, preliminary study on numerical and experimental. Right. So my name is Muhammad Faris bin Abdul Manap and I'm from UITM Pulau Pinang. Alright, so I will divide my presentation into three parts. In the first one is introduction and the objective. The second part is the methodology, and the last one is the result and the conclusion. Right. In my presentation here, before I go straight into what we are aim to do, before that, I just would like to you understand what is the meaning of the THR, or we call it as a total hip replacement. So this is the hip replacement. Okay. So the topic or the paper that I submitted before is the preliminary study before we came up with this product. Okay, so this is the result before we come up with this product, which is the liner. So in total hip replacement, we have four part. Okay, the first part is the hip stem. Okay, in here the hip stem, which is a component used in a hip replacement to replace the natural hip joint. And we have the established shell. Established shell will looks like this one. Okay, mostly from the metal or ceramic. And then we have the established cup liner, or liner lah, we call it. So most of it from the plastic. Usually ultra high molecular weight polyethylene or other material that if you can read from my paper. And the last one is the femoral head, or we call it as a ball lah. So the ball that will be used to ease the movement of the implant. And the objective why I'm doing this research, which is that ultra high molecular weight polyethylene is a popular thermoplastic and used in many applications due to its superiority, which is high impact, wear resistant, and etc., which is better from the other material. However, if you look into my paper, you can see that, however, although ultra high molecular weight is very effective material for the established cup liner, but then it still have a major drawback. Okay, compared to the normal lah, obviously, uh, such as crack, delamination, or wear, or issue that is related with the biocompatibility issue. So my objective in here, okay, we try to mix two material, okay, ultra high molecular weight and also the epoxy, with different weightage and different thickness, in order we want to improve the THR itself. So the most important thing for the established cup liner, does it superior, wear resistant, or impact resistant? Right. So this is our methodology. We came up with the sample formulation and the theory of Young modulus and Poisson ratio. So the equation I will not put in here. It will become much more complicated. So you may refer to my paper. You can see that we use a different weightage and we rename our coding into this part. So this is the method that we want to find the Young modulus and also the Poisson ratio. We have two thickness, which is 3 and 5. Please bear in mind that this is the preliminary result before we came up with this prototype in here. Okay, so you must know that our progress is quite long. Okay, we already proceed into the next step, but this is the result that from the previous step. So in from the result, we can see that as a experiment result attribute to the underlying material properties, and this vary with the variation of thickness and also the Young modulus. Because there is more material available to disperse and to the force of the stress, thicker sampler of ultra high can often sustain greater stress before breaking. So in simple word, we can see that that the higher thickness will should be better compared to the thinner uh, thickness. So overall, we can see that the experiment revealed, however, that thicker sample may also be more brittle. So that means that it is more likely to fracture or break abruptly under stress. Overall, the result of the experiment show complicated the relationship between the properties of material and how it behave mechanically. So the other result, we can see that from the experiment and the theoretical, we can see that from the theoretical, from the equation, theoretical evaluation demonstrate that the increase in the filler content within composite material leads to a reduction of the bonding strength, and those will make the Young modulus become lower. However, in the experimental result, we can see that the variant of the composite exhibit varying of Young modulus values. So it does not normally follow the theoretical value. That is the aim of my project in here. Okay, because we can see that the numerical and experimental data suggest that augmenting the filler content to 5 weightage percent result in a decrease of Young modulus. So this is one of the example. We can see from the graph that the experimental is varies. Okay, depends on the content, but then it does not follow the theoretical value. So the other result we can see that is for the void using the optical microscopy, the distribution of ultra high molecular weight polyethylene particle inside the epoxy resin for different weightage and proportion. We can see that comparison between the lowest and highest variant ultra high molecular weight PE particle initiate void region in the EP-UHMWPE1 variant for both statement condition. Meanwhile, EP-UHMWPE5 do not exhibit clear void region for both thickness and condition. Technically, you can see that greater void region will reduce the mechanical properties due to the bonding of the particle. However, the data from the experimental shown otherwise. Okay, so why does it happen? Okay, so why is it happen? We can came up with this conclusion. So there is a study conducted that any right amount of filler will improve the composite properties due to void limit rejection, or we call it void rejection limit. In simple term, void limit could affect mechanical properties depending on the weightage and does not necessarily follow the rule of high void limit reduce mechanical properties. So this is one of the main point or main result that we can get from my experiment in here, in which that it does not necessarily follow the rule by the books or by the theoretical. We must do the experiment to consider the other things or other factor. So microscopic shows that an equal dispersion of ultra high molecular weight polyethylene in composite may be accomplished. However, we can see that an excessive quantity of ultra high molecular weight PE particle may not always result in improvement in mechanical characteristic due to existence of void. So you can read more details in my paper. Okay, so we can see that it does not necessarily follow the theoretical, like I mentioned previously. So I think, like I mentioned, this is my result or preliminary work before we came up with this PO1. I call it as a PO1, which is the prototype. So this is the real implant, and then we try to build prototype from the two material, compare with this only ultra high. You can see from my picture in here. All right. So uh, this is the finding that we can get, although it is not very greater result, but then I think it's quite important for us to understand the importance of the void and also the limitation of the filler. Right, and that's all from me. This is me and also my contact number. And thank you. If you want to collaborate or anything, you can get in touch with me, and I can say thank you very much. Thank you also for the organizer for this virtual presentation. Hopefully that you can enjoy my short presentation in here. Thank you.